New large language models are popping up every week since the Facebook Llama model leak. Many people already figured that one of the most important part of the large language models, or to make them useful, is to be able to tune them. One of the best tuned models at the moment that are available for everyone to use is GPT4All. It was tuned on 800k prompts, and all those prompts were generated using the GPT-3.5 Turbo. This has the implication that this model cannot be used for commercial use, but you can still play, run the model, see how it works, try to tune that model with your own prompts, and maybe even try to reverse engineer some of the work. So what I would like to show is how to run this model in a notebook. The idea for this came looking into the generate Py file, but also in some of the notebooks that were publicly available from other people publishing it in the internet. My code is going to be based on the information that you're going to see within this file here, but we are going to run this using a OCI data science notebook, and we are going to run this on GPU. The notebook that you will see in this video will run actually also in your local environment, as long as you can install PyTorch, or if you use Conda environment, just install Conda environment with PyTorch dependencies inside. Some of the additional dependencies that will be required to run this notebook are actually also inside the notebook itself, and I'll demonstrate you how to install this. So when you open your Oracle Cloud Data Science Service notebook, this is probably the first window that you're going to see. If you don't see this window, you can always open it by clicking the plus icon here on the top left side, and this is going to appear again. So for our notebook, we're gonna need a PyTorch installed, or at least PyTorch Conda environments. Conda environments are already pre-configured and available in our notebooks. You have to, however, install the specific libraries that you need. And we have some of those already pre-configured and ready. To get one of the pre-configured ones, you just go to the Environment Explorer. In my case, I'm running this notebook on a GPU shape, so I'm going to select as architecture the GPU, and then here I'm going from the Conda environments, I'm going to select the data science one. The next steps are the one that you have published and also the one that are installed. In my case, I'm looking for one that I would like to install, and this is the Conda environment that we need. So I'm going to expand this here, click on copy to copy the CLI that will install this Conda environment. Go to the Launcher Explorer again, click on Terminal. And here in the terminal, I'm just going to paste this command and hit enter. And this is going to take a minute or two. The Conda environment will be downloaded to your notebook and will be installed. So as you can see, the installation was successful now for me. I can continue working. We can check with the existing Conda CLI that you know if the Conda environment was installed and which Conda environments I have available. As you can see, this is the Conda environment that I just have installed. We can copy this and just use Conda activate and paste this path, and as such we just activated this Conda environment. So let's keep this terminal now here for a while, and we are going to open the notebook that we are going to use for today's exercise. Here on the top of the notebook you will see a link to the project that inspired that notebook. You will see some of the comments that also exist here on the top of the notebook, give you some idea of what I use, so you can just copy and paste those here directly and use them in the terminal. The next thing that it's important to do is we have to install these dependencies to be able to run the notebook. So let's start copying them one by one and install them using the terminal. You can also use the notebook to install them, but I usually prefer to use the terminal. I like it better. So let's copy the first one, go back to the terminal, make sure that your Conda environment is activated, and just paste this here and wait for the libraries to get installed. And just after a few seconds, all the libraries, all the dependencies that we want to run installed. Go back to the notebook, get the next one, which is the Hugging Face transformers. Paste this one here. So we're going to install that one as well. This is going to take a little bit time. All right, this is done now as well. And let's get the last one. We're not going to install the bit and bytes. We're not going to run this as 8 bits today. So let's paste this here and install it as well. All right, this one is done as well. So let's go to the notebook. The next thing you have to make sure is that we select the right Conda environment here on the top right side. So now we can start executing the cells. The first cell is just to check that the GPUs are connected and available, especially that I'm using a notebook on a GPU shape. I also like to put a code to check that the PyTorch is able to use the GPUs. And then the next one that is just running right now, we are loading the LLaMA model. Now something interesting here is that you can load the LLaMA model and the LLaMA tokenizer without loading the tuned GPT4All checkpoints, which is interesting because it gives you the ability to try to use the LLaMA model directly. You can send the questions directly to the LLaMA model first and see the difference in the response between the pure LLaMA model and the GPT4All tuned model. So let's load the tokenizer. When we tried to load the LLaMA tokenizer, we actually got the error message. The error message was that the tokenizer is required was version 0.13.3, but the version that we have was an older version. And that's probably a good opportunity to try ChatGPT and see if the ChatGPT will give us a good suggestion to fix it. So it's obvious that we need to upgrade our tokenizer. So I just paste the error message here without us asking any specific question. And looks like the ChatGPT is able to recognize it. We can test and ask the same question, the GPT4All, after that and see what response we're gonna get. So let's get this one, go back to our notebooks and go back to the terminal. And again, just make sure that your Conda environment is activated when you do this, because this is the Conda environment that we're using, and we have to install everything within this Conda environment. Paste this here, enter, and let's upgrade it. So we have successfully installed Tokenizer 0.13.3 version. So let's go back here and let's try to rerun that part here and see what's going to happen. Okay, so after we load the Tokenizer, we have two options. One is to load the GPT4 weights and models so that we can work with the model directly in the notebook, or we can decide to skip that cell first and just try the LLaMA model directly, and then we can compare the answers between the LLaMA model and the tuned LLaMA model with the GPT4All. Now I did this already in advance. I have a small function here which is generating the responses. So I'm providing the prompts and then some configuration about how creative the model could be, and then I'm just printing out the output. Now the first thing that I tried was the LLaMA model, and I used something that I've seen other people do in their notebooks as well. Ask a question like, what are the differences between alpacas and sheep? Notice that you can prompt the model using the function that provided above in 3 different ways. So this is one way you can prompt it, but you can also just prompt it directly with the question, or you can provide the question in array. Now, once I execute this against the LLaMA model, it provided me actually a good response. Probably not that human-like, and it's counting a lot of features, but it's still a reasonable response. When I try against the GPT4All, the tuned LLaMA model, you can see the response is a little bit more human-like. So it's a little bit more readable, a little bit more something that you would expect a human would respond. The next thing that I try is against the LLaMA model, I ask what are the top 5 biggest banks in the US, and that was very surprisingly, because it just responds to what is the difference between a bank and investment company. That's something I didn't expect it. I run this only once. Maybe I shouldn't run this question a few times to see if it's going to change it. But this was the first response that I got from the LLaMA model. At least that was for me. When I asked the same question, the tuned LLaMA model with GPT4All, I've got now a reasonable response. The 5 largest banks in the United States by assets of March 2019, and then it named the banks. This is actually already great response. Now the next thing that many people would like to do is to provide them a lot of text and to ask for summarization. So I got this text for Berkshire Hathaway 10K report, it talks about a cybersecurity risk, and I just asked the LLaMA model, read the text below and summarize the cybersecurity risks into 1 sentence. And that was interesting because the response from LLaMA model was not really a summarization. As you can see, it's basically the same text, but more, or just written in a different way. So it's not really summarization. When we try this against the GPT4All, so the tuned LLaMA model, that response was now something better. So it's not 1 sentence again, it's longer than 1 sentence, but if you read the text, you'll notice that it's more like summarization of the existing cybersecurity risk text. So that's a little bit more compacting it. So it's a way better response than untuned LLaMA model. Something else I wanted to try is to see how well it's going to code. This is a very simple question to write a Python function to detect the number is a prime or not. So first I asked the question, the untuned LLaMA model, and the response was this function here, which actually works okay. Something that was not there is that import math. So as you can see here, is using the math library, and this was not actually specified in the response. So if you just copy the function and execute it, it will throw you an error that the math package is not there, so you have to import it. But even though it looks kind of okay, if you try to test it, you will see that it doesn't work well. So it's gonna say that number 1 is a prime number. Let's try another one, which is 5, which is okay, 7, very good, but it's not the perfect function, so it makes a mistake. So for example, again, it just says that 1 is a prime number. Now this was the LLaMa model. When I tried the GPT4All model, the first is 15 a prime number? Can you give me an example for another prime number and describe what prime number is? It gave me a very good response actually. It shows to know what it is and why something is a prime number, and even gave me another example as a prime number 7. However, even though it knows what prime number is, it responds that 15 is a prime number, which is actually not correct. But then when I ask him, write me a Python function that can detect if given number is a prime, it throws me this function here, which is okay. And by the way, it's interesting that if I just use exactly the same question that I asked the untuned LLaMa model, if I hit this here, you will notice that actually responds with a function that it's not correctly formatted. So if we paste this here, you will notice that well, that's not at the right place. It has to be like this. But this function is totally wrong. So it's going to give you 1, let's say 5. It's going to say that it's false, 7. So I try to change a little bit the way of how I'm asking it. So I ask it like this. This is the GPT-4All model that we are executing now, the tuned LLaMa model. So this produced something that's a little bit better. It is basically the same function, but now it's at least better formatted. But if you try this function, you will realize that this function is actually very wrong. So it gives you all prime numbers as a false. So I asked GPT-4, can you give me the first 5 prime numbers? And that's something that was able to pick up correctly. So if you're asking for the prime numbers is okay, but when we ask him to create the Python function, it didn't work very well. So that's not really very good starting for the Python developing. Maybe you can test it more and see if you'll produce code for some other type of questions, some more complex questions. The last thing that I wanted to try is, if you remember the problem that I have with the tokenizer. So this is the same error message that I use in ChatGPT. So I just copy and paste the same error here, and I just hit. This is against the GPT4All, and this was actually very good. So it's basically provide the same response, that the library is actually older. It says the command line interface required, so I don't know how exactly it comes up that this is a command line interface, but this one here is correctly. Please update your installation by running pip install upgrade tokenizer. So this response is a reasonable one. It's very similar to the one that we got from ChatGPT, but it provides less explanations. So that's it for today. I hope you learned something, and if you don't have an Oracle Cloud account yet, just go to cloud.oracle.com, click on sign up, and you will get always free access to some essential services. And if you register for the very first time, you'll get $300 of credits for 30 days of use, where you can also use the Oracle Data Science service.